Greetings to the whole world. Again, it's Lwandile here, the leader and the instructor of Manikwe School. Right now, what we want to do is to check on exercise 5.16. Okay, so the task on hand here will be to simply write a program that reads an integer and displays all its smallest factors in increasing order. Okay, so for instance, if the input integer is 120, then the output should be as follows: 22235. Okay, and if you don't quite understand what is required of you at the moment, you can sit down with the pen and the paper. It will all add up. I can assure you, I had the same problem at first. Just by reading this question, it wasn't pretty clear for me what is actually required to do. But I can assure you it's pretty straightforward. Okay, so here's the thing. Of course, what we do want is a scanner, so we gotta create a scanner. Do read user input, of course. Okay, and I'll call my scanner input. In the end, if I did not forget, I've got 2 questions for you guys on this exercise. Hopefully I am not gonna forget. Okay, so we wanna close our scanner, so it's gonna be input dot close. Okay, with that out of the way, what I want to do now is to prompt the user to enter what? A number. Cool. Okay, I'll store that as an integer. Of course, you can get away with this using a short data type or perhaps a byte, but a byte won't be best of a choice because it will limit you, but a short would do it, I can assure you. Anyways, let's continue. Okay, so I'll simply go input.next int. So far what we're doing is pretty straightforward. Oh, by the way, here's my nephew over there. He might be annoying by making noise, but let's hope he won't. Okay, let's see. Let's validate first. So here's how I'm gonna go about my validation. If number is equals to 1, or number is equals to 1, if this is the case, I'll simply go system.out.print okay, your input value isn't allowed. Okay, of course we want to exit our program afterwards. System.exit, and we want to put a 0 as our status. Let me maximize our working space here. Okay, enough with validation. Now let's get to the core of the problem. What I want to do is to make sure that I have a variable called products that will actually tell us whether or not to keep going computing what we're actually computing. Okay, oh, by the way, there was a person greeting, and I'm so sorry if that did get on our way. Okay, so what I was trying to say is we create a variable to hold the products, and that product will be the products of these numbers, because at first you'll have 2, so the current product in that case will be 2. Once we retrieve the second 2, we'll then have a product of 4, and then after that we'll have a product of 8. After that it's gonna be 8 times 3, which is 24, and then finally it's gonna be 24 times 5, which is gonna give us 120. So that's what this variable I'm about to declare will hold. It will hold the current product, okay. In fact, now that I just told you how it works, there's no need for me to comment it out, okay. I'll simply go products, I'll initiate it to 1, and then another thing or another variable will be called divisor. Okay, in this case, in this example, our first divisor was 2, our second divisor was 2 again, third one 2 again, and the fourth one was 3, and then finally the fifth one was 5. Okay, so again, there's no need to comment out that now that I just told you guys. Okay, so it is time now. Okay, what else I want to keep track of? I want to hold these numbers here, these devices, in a list. But what I'll do is I'll have a string to hold all of my devices. Okay. Now what I want to do, I'll initiate my variable that will actually hold the positive original number that was given by a user. Why am I keeping this number? Why did I specify the word positive here? Original. Let me finish first. Positive original number. That is because a user might probably give us a negative number. So that's why I thought it would be better to have this number here. Again, folks, my solutions aren't the best solutions one can find, but I'm just sharing my thoughts. That's basically what I'm doing. Okay, so here's what I want to do right now. I want to go while. This is the core of this problem here. So I will simply go while products as less than positive original number. While there is the case, what I'll simply do, I'll check if number is divisible by divisor. I'll check if number it's right up there. Okay, I'll check if number is divisible by divisor, and if the answer is yes, then I will know that I have my divisor. What I'll simply go, I'll concatenate that divisor with I'll simply concatenate my factors. I forgot S there. I'll simply concatenate my current factors with, then again, here we go, people are yelling and talking and she went away. Okay, I was saying factors are okay. What I want to do is to concatenate my new divisor with my current factors. Okay, and then I wanna separate them by a comma. Oh, you know what? Let me use a space, because that is exactly what they used there. They used spaces. Oh, commas. Okay, I'll put a comma. Okay, now that I've updated my list of factors, what else I want to do? I want to update my number variable, and I'll simply do that by dividing my current number with divisor. Okay, and then lastly, product. What I'll do is to go product multiplied by divisor. Okay, so on the first iteration, this product on this example over here, on this scenario, will simply be 1. And on the second iteration, it will be 4, because we'll be having 2 multiplied by 2. Okay. Okay. I mean, that should be it for that part. And then what I'll do is I'll say, in case my number isn't divisible by divisor, I'll have to increment my divisor. If a number isn't divisible by 2, I'll try 3. If not, I'll try 4. And if not, I'll keep continuing until that is actually taking me back to another condition, and divisor is less than. This is for you guys to do a little bit of research. You see, if you did a greatest common divisor problem, you would know that a more efficient algorithm, or rather way to go about solving that problem, is to go starting from 2 up to the square root of a number. I mean, given a number n, you're just starting from 1 or maybe 2, however you want to think of it. You start from 1 or 2 up to the square root of that number n. That's a more efficient way of checking out if there is a number that divides that number n. Or maybe you can go from 1. A less efficient solution will be to go from 1 up to up to half of that number n. Okay, up to n over 2. I mean, a more solution which is less efficient will be to go from 1 up to that number itself. In this case, what we'll do, if we had to use that solution, we would do this. So we'll simply say we keep continuing while divisor is less than number. Okay, but I don't want us to do that. I want us to do this. Again, I know some of you might make an argument out there that perhaps this solution I just added is unnecessary. Okay, that's number 1. Okay, I mean, that should be it. You know what, let me just print out the solution and talk later. System.out.print. Let me display the solution. I'll go the factors of number are the factors of number are, and then I simply display factors. Okay, I forgot something, and that is to remove the very last comma on my factors variable. Okay, and that is pretty straightforward. I can do it right there at the top. So factors is actually given by factors. We're gonna use the substring method to get rid of the very last character. So we'll go factors dot length minus 1. We're removing the very last character. Okay, let's hit the run button and see what we get. Let's put a number, the very same number they decided to put in here, okay, which was 120. Let's see. Could I possibly have missed displaying a thing here? It seems like I did. Oh my god, that was so stupid of me. How could I possibly do that? Okay, what I want to do is to prompt a user to enter. Okay, so here's what I'll do. Let me prompt a user system.out.print. Enter a number. Damn, I feel like I've taken too much time now. Enter a number. Done. Oops. Yeah. I'll put 120. And if I made any mistakes, you're gonna have to bear with me. I'm gonna have to check them out. Oh, I forgot we didn't include 5, the very last number. And why was that? I'll tell you in a sec. Really, did I just do that mistake? You see, number 1, what I did is check this out, folks. You see, the factors of 5 are those, and that tells us one thing, that I made a mistake. I printed here, I should have printed original number, right? Positive original number, because this positive original number won't be modified as we go on. Okay, and then secondly, it seems like we have got to concatenate the very last number that will be remained on our number variable. Okay, the very last version of number, and that is exactly 5. Okay, in fact, what we can do is we can simply do that. Okay, now let's hit the run button and see what we get. Oops. See, I've been recording a ton of videos, and it seems like now I can no longer work with them. Okay, you know what? Here's what I'll do. I'll simply concatenate there with number. Problem solved. Because I've had a long day, a long hell of a day. And if I do that, there won't be a need for me to remove the last comma. Now that this shit works, I've got a question for you guys. Okay, you know, guys, if you noticed, what I did here is on my else part, that's where I incremented my divisor variable. Question is, wouldn't it be better if we simply get rid of this portion and then put an inner loop here which will start from 2 and then go onwards? It's just a question. I'm not saying it's the right thing to do. I'm just asking you guys. So basically the question will then be, does it even make sense to do such a thing? So check this sample out. Would we ever find an integer n such that we'll get these numbers and then eventually we get a number that is is less than some numbers to the left of it. I don't know if that does make sense to you guys. So please feel free to ask any questions you have, and please let me know what are your thoughts on this problem. That should be it, you guys. Cheers. I'll see you on the next one. I'm